All right. Time to resume. Advent of code. Where are we? Day 24. All right. Took a little break for all the stuff surrounding Christmas. Baked some wonderful things. Ate those wonderful things. Got some wonderful baked goods by mail. Ate those things as well. So now I'm fat and happy and ready to continue. Advent of code. So let's get started. Day 24. All right. Lobby layout. I always forget to do this until the end, so I'm just going to do it right now. I'm going to do, this is day 24, and it's lobby layout. Let's just copy this into the README right now. And I will grab, somewhere I have the key for this. There it is. All right, where are we? Bam, done. All right, so we got lobby layout. So let's read it. Your raft makes it to the tropical island. Well, that's awesome. I think last we were fighting a crab. Well, we were doing crab cups. Oh my god, forgot about crab cups. That was hard, but good. All right, turns out that the small crab was an excellent navigator. That's awesome. You make your way to the resort. As you enter the lobby, you discover a small problem. The floor is being renovated. You can't even reach the check-in desk until they've finished installing the new tile floor. The tiles are all hexagonal. Ooh, hexagonal grids. Yeah, they need to be arranged in a hex grid with a very specific color pattern. Not in the mood to wait, you offer to help figure out the pattern. The tiles are all white on one side and black on the other. They start with the white side facing up. The lobby is large enough to fit whatever pattern might need to appear there. Okay. A member of the renovation crew gives you a list of the tiles that need to be flipped over, your puzzle input. Each line in this list identifies a single tile that needs to be flipped by giving a series of steps starting from a reference tile. In the very center of the room, every line starts from the same reference tile. Okay. Because the tiles are hexagonal, every tile has 6 neighbors: east, southeast, southwest, west, northwest, northeast. Okay, these directions are given in your list respectively as E, whatever. Okay, a tile is identified by a series of these directions with no delimiters. For example, east, southeast, northeast identifies the tile you'll land on if you start it. Okay. And that's fine because there's a limited number of things. Where were they? E, S, E. So if it starts with an S or an N, then we need to know the next one. If it starts with an E or a W, then it's just east or west. Each time a tile is identified, it flips from white to black or from black to white. Tiles might be flipped more than once, and they start as white or white. Okay, they start with the white side facing up. Each time a tile is identified, it flips. Okay, tiles might be flipped more than once. For example, a row like east, southeast, west flips a tile immediately adjacent to the reference tile, and then a line, okay, flips the reference tile. It's in northwest, west, southwest, east, east. Flips the reference tile itself. Here's a larger example. In the above example, 10 tiles are flipped once to black, and 5 more are flipped twice. After all of those instructions have been followed, a total of 10 tiles are black. Go through the renovation crew's list and determine which tiles they need to flip. After all of the instructions have been followed, how many tiles are left with the black side up? Okay, that's cool. Let's copy this, and we'll talk about how we plan to solve it. So first we're going to need a new folder. I call it day 24. Cool. Here we go. Open new file. On the coffee. Bam. What just happened? All right. There we go. There we go. I don't know what happened there. I quit Sublime by accident. That happens occasionally. Here's a larger example. So this is going to be our input. So let's get that in. Input. And we're going to go down there. Okay. Go through the renovations. Okay, how many are black side up? So this is in the above example, 10 tiles are flipped, and 5 more are flipped twice. After all of these have been followed, a total of 10 tiles are black. So this is what we need to assert in the tests. So we're gonna make our definitions, our tests, and then we're gonna run the thing. Okay, so in our test section, we want to assert that 10 is, and then we're gonna have to figure out how we're gonna calculate 10. That's what we got to do. So a couple things we can do to set up. First of all is we're going to pull in log, so I don't misspell console 100 times, which otherwise I will do. And we're going to require assert, so we can assert that what we write is correct. And then, all right, general talk about how we're planning to do this. So one thing that's interesting about hex grids, I've actually been researching them recently. So I was thinking about it would be really cool to have hexagonal solar panels, because it would allow you to change the number of strings in series and the length of those strings dynamically, because you've got options for how you connect them together. You could connect them together in shorter groups or longer groups. So like as the sun comes up, there's less light hitting them, so the voltage is low. So you would want a longer string to hit a high voltage to charge a battery or run equipment. And then as the day goes on, you would want a shorter and shorter string to hit that same voltage, and then you could use the rest of the strings for other jobs. Maybe you could have maybe 3 of these or 5 of these in parallel. Anyway, it's interesting. So researching hex grids, one of the things that is a common strategy for dealing with them is to think of them as a cube, as like a cubic grid. So for instance, like a normal like grid, like you've got this grid down here, right? You've got x coordinates, and then you've got like y coordinates. So when you're dealing with hexagonal grids, they have 6 sides, which is similar to a cube. A cube also has 6 sides. So you could think of a hexagonal grid as having sort of like it's got the east-west, so it's got the x-axis, and then it's got a y-axis which goes this way, and then it's got a z-axis that goes this way, which is similar to a cube. So a cube, you would have x-axis, y-axis, and then z-axis like this. But really, it's the same number of axes, and that's really all you care about, is having 3 dimensions. So I think maybe that it would make sense to use that sort of a strategy for dealing with this. So like southeast would be, so like the southeast northwest axis would be one of them, would be maybe like y, east west could be x, and then southwest northeast could be z. And that's a way of tracking where you are. That way you have whole integers about what direction you're in. So that's how I'm kind of planning to hit this, and I don't see why that wouldn't work. So let's give it a shot. Cool. So first thing we need to do is we need to parse this input that we've got. So this is just a series of moves. I don't think the new lines matter. What we just need to do is we just need to consume all of these tokens and figure out what this does to our 3-dimensional grid. So really a 3-dimensional grid, all we're doing is we're tracking a couple things. We're tracking the current position in X, Y, and Z. and we're also tracking whether or not it's on or off. And every time we hit one of these things, we want to turn it on or off. So how are we going to represent that as a data structure? We could represent it as a series of nested arrays like this. So we could have X, Y, and Z. So that's one way we could do this. Another way we could do this is we could just have we could just have a tiles object where we say X, Y, Z, and we could like add them together, and we would also need to figure out what the current position is. I mean, we're gonna have to track that either way. And then we can set that equal to either like 1 or 0, depending on whether or not it's flipped or not. So I'm gonna assume all of them start with 0, which would be white, and then 1 could be black. So 1 would indicate that we flipped it, and then if we flip it again, it would go back to 0. We could also track these with true and false to say whether they're flipped. In fact, let's do that. Let's do true / false. So false is unflipped, which would be white, and then true is flipped, which would be not white. That way we can set a tile equal to not itself, and then that would work every time we flip it. Cool. So I think this is what we're going to go for. We're going to go for this data structure, and so we're going to have to figure out which axis we want to be what. So I feel like we're going to start with X being left and right. So that's west, east, or west, east, depending on how the camera is flipping me. And then as we go clockwise, we'll go Y and then Z. So that would make northwest, southeast would be +1, -1, and then northeast, southwest would be +1, -1, and then east would be +1, -1. Anyway, it's not like it matters which we assign, we just need to be consistent. Cool. So first step, we're gonna need to parse the input. And parsing the input means we're gonna try and find these tokens. So every time we see a southeast or a northwest or an east or a west, excuse me, we're going to need to process that as a token. So one of the interesting things is we're going to have a series of tokens. We're going to have an east, a west, southeast, southwest, northeast, northwest. These are the tokens that we're going to encounter. Basically, if it starts with an S, we're going to have another character. If it starts with an N, we're going to have another character. And if it's an E or a W and we're not already expecting that other character, then it's just done. So we're going to need a way to consume these, but we need to try to be greedy about it. We might be able to do this with a regex, just split this into like a greedy regex. So let's try that. Let's try that and get moving. So let's parse input input, and let's log the result of that. And so let's write parse input. Okay, so it's going to give us a wall of text. Wow, it's gonna be one of those days, guys. Parse input text. Okay, so we got text dot, what are we doing again? Yeah, we're gonna match. Okay, so we want to match this string on a regex. Is it regex match or is it string match? I can never remember. I think it's regex test and string match. So we're gonna look for and we want this to be as greedy as possible. So we want it to be southeast or southwest or northeast or northwest. I don't know if this is going to work, or east or west. Oops. And we're going to have that a number of times, and this is going to be global. And let's see what we get back. I think they gave us an example, like a shorter example that maybe we should play with. Let's look in the browser for it. Xgrid, flipped over. So for example, Oh, here we go. So let's just do this first. Let's parse input of this guy and see what we get. That would give us northwest, west, southwest, east, east. So let's see what we get. Nope. Oh yeah, we want to beginning, and oh, this is going to give us a capture group of these repeating, and we don't want to do that. What we want to do is we want to just look for them. Okay, northwest, west, southwest, east, east. So that's correct. I wonder if and let's make sure that the length 1 2 3 4 5 6 7 1 2 3 4 5 6 7. Okay, good. So that's working, and I wonder if maybe the input will do as well. Input. So let's see if this works as well. 267 more items. So let's just grab some random. So we got southeast, southeast, northwest, northeast, northeast. I guess the easiest way to do this would be to test the input length. So that's what we're going to do. We're going to say log input dot length. Then we're going to grab the parse input, and we're going to join that with nothing. Just going to glue it back together and test the length and see if they're the same. They're not. Okay, so we're actually missing. We're missing some stuff. It could be the new lines that we're missing. So I think those count as a character. So let's check that. So let's say parse input dot replace, and let's replace. Can I do that? And let's get rid of that output. 638, 620. No. Global. 620, 620. Okay, so there's 620 characters, and we're parsing all 620 characters. So, cool, that works. So basically what I was doing is I was seeing if the number of tokens that we are pulling out of this, when they're glued all back together just as tokens, is the same number of characters that we're finding, or the same number of tokens that we were. When the tokens that we found are glued back together, I wanted to make sure that they're all here, basically, that they equal the same number of characters. And they do, which is good. It was giving me a different number, but that's because it was counting a new line as part of the string, as a length of 1, and there were 19 new lines. Cool. So we've got these. So that's pretty easy. So parse input is giving back an array of steps. And now what we want to do is we want to process those steps. And so we've got east, west is X. This is going to be X. And then southeast, northwest is going to be Y. Okay. And then let's, so this is going to be X. Whoop. It's going to be Y. And that's going to be Z. So southeast is going to be, it's going to be minus Y. Southwest, oh, sorry, this is going to be Z. Southeast, northwest. No, it's going to be northeast, southwest is Y. No, I was right. It's going to be, so X, Y is going to be southeast, northwest. Negative Y plus Y. Plus Y. Okay, and then we're gonna have, it's gonna be Z, it's gonna be southwest, northeast is gonna be Z. And then east is gonna be, all right, well, gonna be plus X. Okay, and that's gonna be minus X. Cool, so this is basically the map of how we're gonna move things. We're gonna have, west is gonna be subtracting X, Y is going to be, our east is gonna be adding X, then southeast is going to be subtracting y. So y is on that axis. Southeast is going to be going. It feels weird, but whatever. Anyway, it doesn't even matter as long as we're consistent. Cool. So we're gonna move, and we're gonna move one of these for each one. So we're gonna have chords, and that's gonna equal. That's gonna be 3 integers. I guess what we can just have is we can have x, y, z, and then we're gonna have a direction. And what we're gonna do is we're gonna return x, y, z, and then in here we're gonna modify one of these based on the direction. So, and we're also gonna have to flip these somehow. We could represent this as a class, so we could store our direction in the class and also our state in the class, but we might not need to. So let's just see how this works first. Okay, so the first thing we're going to have to do is we're going to have to modify x, y, and z. We're going to have to move to that square. Switch dir, and then when. This is when these come in handy, I guess. Here, let's put them in here. We can just say, when. What are we doing here? We're going to say x, whoops, x minus equals 1, x plus equals 1, okay, and then we're going to have y, I know it's not plus equals 1, I'm just going to put them in here. Okay, and then this is going to be minus equals. So cool. So now we've moved, and now that we've moved, so northeast is going to be that z plus 1, southwest. Okay, cool. And then we're going to return x, y, z. So that's going to be our new x, y, z. This is going to be move. This is how we move given the direction. And that'll give us the new square. So now what we need to do is we need to basically, for every token in the input, we need to move, then flip, and then move, then flip, and then we're done. So lay tiles. This is going to take a series of moves, and it's going to have a floor, which is just going to be a hash, basically. So for move in moves, so that's for direction, basically. We're also going to start off with x, y, 0, x, y, z of equals 0, 0, equals 0. So we're going to start at 0. And we're going to start with empty floor, and we're going to insist on having a series of moves. So this moves is going to be an array. So for move and moves, what we're going to do is we're going to say x, y, z. It would be good if I typed it correctly. Y, z equals move. X, y, z, and the move. Oh, we can't say move and move. For dir in dirs. How about that? This is going to be directions, because we've already got a function called move. Okay, so we're going to move those. Then what we're going to do is we are going to look at our floor, and we're going to say floor at xyz join. I guess we can just say join it with that, or we can join it with a comma. Yeah, okay. So floor xyz join with a comma. So this is going to be our tile key. Oops. Come here. Copy. There we go. Tile key. Do that, and then we're going to join it. Floor on our tile key equals not the floor on our tile key. So if it was not flipped, it will become flipped. If it was flipped, it will become not flipped. And then at the end of this, we're going to return our floor. So, all right, let's try this. And they said the larger example, a total of 10 tiles are black. So we're going to get a floor back, and then what we want to do is we want to count flipped tiles in that. Oh wait, let's do this with L for some reason. And this is going to take a floor, just like that. There we go. And we're going to say for key val. I guess what we're going to do is we're just going to get the values. Dot values floor. And we're gonna count the trues. So we're going to for t in. This is going to be the vowels. We're going to just say, okay, num equals 0. We can put that up here. Num equals 0. Why not? We can say num plus equals 1. Just put that there. And then what we can say is return num. So count flip tiles of laid tiles. Okay, so we're going to count flip tiles with the return from lay tiles. And that's it of the parse input, which is going to give us just dirt. So let's see what that gives us. Okay, so that's angry. Because this is not how you do this. We could put this on new lines, or we could say then. 236. So that's not correct. Oh wait, that might be correct. We don't know because we actually haven't. Oh no, that's certainly not correct, is it? In the above example, 10 tiles are flipped once, and 5 more are flipped twice. So this is not correct. It should be a total of 10 tiles are black, and we've got 236. Okay, so time to start debugging. So let's log what lay tiles gives us. All right. So the first move is southeast, so that should be -1 on the y-axis, and that is giving us that. And we flipped that to true. Then the second move is southeast again, so that's -1 on the y-axis again. And then we go northwest, so it backtracks. Okay, I mean, yeah, so this seems like it's going, and then northeast would go up that way, and then northeast. Yeah, I mean, that seems reasonable to me. So, okay, so let's check these. So west is -1, east is +1, southeast is -1 for y, northwest is +1 for y, so southeast, northwest. Then we got southwest is -1 for z, and northeast is +1 for z. And then we return the new XYZ. I mean, are we ever hitting something else? Log. Oh my god. Let's see. Do we have any oh my god ders? No, we don't. Okay, so we're not ever getting unexpected input. That's good. And these are so floor tile key. So let's log this. Log tile key, and then we're gonna log floor tile key, and then we're gonna log not floor tile key. All right. here we go. Come on. Actually, we can go all the way up to the top. All right. So, -1 was undefined becomes true. Was undefined becomes true. Was true becomes false. Yeah, this seems to be working fine. So the question is, can't flip tiles. Parse input is giving us an array, which is correct, and it seems to be doing all these things. So count flipped tiles for 1t 173. Nope. So let's take a look at. So this is just counting the number of floor tiles that we've been at, so that's a problem. So that's why we're getting 236. But we definitely got more. We definitely got more than 10 trues, which means they've been flipped. And I'm pretty sure that's what we're supposed to be counting. In the above example, 10 tiles are flipped once, and 5 are flipped once, and 5 more are flipped twice. Okay, maybe we don't understand the question. In the above example, 10 tiles are flipped once, but every time you touch a tile, it should flip, right? Maybe not. Maybe that's where we're screwed up. All tiles are white and black on the other. You start with the white side facing up. The lobby's large enough. Okay, a member of the renovation crew gives you a list of tiles that need to be flipped over. Oh, each line is a map to the tile they want to flip. Okay, so we understood the question improperly. I was thinking like Go, where you touch a tile and it flips. But what we want, I don't even know if that's how you play Go, actually. What we want is rather than to flip every move, what we want to do is we want to break these into lines. And then for each line, we want to get to the end and flip that tile. So that's what we'll do. And we can actually reuse a lot of this. So that's cool. So we're going to lay tiles. So what we're going to want to do first is, okay, we're going to have to change our parse input. We're actually going to have to split on a new line. And then for each new line, what we're going to do is we're going to have, we're going to map it. Say line, and then we're gonna line dot match that. So let's see what parse input gives us now. It should be a pretty quick refactoring. All right, cool. So we've got okay, so this should give us like 19 lines. All right. And the last one is starts with west, ends in west. Starts with west, ends with west. Yeah, okay. So that seems right. So we've got now an array of moves. So parse input's going to give us an array of moves. And then lay tile is going to give us instructions. We've still got our floor. And for instruction in instructions, or I guess a ders in instructions, and then for direction dir, what we're going to do is we're going to start with X, Y, and Z. So we're gonna reset this every time. So we're gonna reset X equals Y equals Z, oops, equals 0. Okay, so we're going to reset X, Y, and Z coordinates, and then we're going to move in that direction, and then at the end of, at the end of that instruction, actually, let's do that in here. Okay, so at the end of that instruction, we're going to have a new X, Y, Z. We're going to get a new tile key, and we're going to flip that one key. And then at the end, we're going to return our floor. And then that is going to be the same. So we're still starting with a blank floor. Now we're starting with an array of instructions where we reset X, Y, Z. We follow those directions. and we flipped the last tile. We flipped like the resulting tile. So let's see what this gives us. Right now we're just logging parse input. And so that gives us 20. So that's wrong. Total of 10 of the tiles are black. 5 or more flip twice to black, then back to white. After all of these instructions have been followed. So that's interesting. So why is it giving us, at least it's giving us a better answer this time. Go through the renovation crews list in terms, okay. In the above example, 10 tiles are flipped once and 5 more are flipped twice. So we've got our instructions and we're resetting XYZ between runs. Let's log these. Okay. And it's saying that 10 tiles are flipped once and 5 more are flipped twice. So really what we want to do is we're going to want to see 3 of these cases or 5 of these cases where there's 2 that are identical. So let's start looking. -4, -3, 1. So -4. Nope. -1, 1, 2. -1. Nope. -1, -1, -2. So -1, -1, 3. And -1. Nope. -1, -1, 3. Nope. 0 and 1. 0, 1, -1. I'm not seeing, so these don't seem to be 0, 1, -1. These don't seem to be matching up. Like this is giving me 20 tiles and the tiles all seem to be unique. So maybe we are doing it wrong. Okay. The above example, 10 tiles are flipped once and 5 more are flipped twice. Oh, it's yeah, we just it's the resulting one. Oh, let's check again. Okay, the tiles are all hexagonal. They need to be very okay. The tiles are all white. A member of the renovation crew gives you a list of the tiles that need to be flipped over. Each line in the list identifies a single tile that needs to be flipped by giving the series of steps starting from a reference tile in the very center of the room. Every line starts in the same reference tile. So that's our 0, 0, 0. Because the tiles are hexagonal, it has 6 neighbors. These directions are given in your list respectively. A tile is identified by a series of these directions with no delimiters. Yeah. Each time a tile is identified, it flips from white to black or from black to white. Tiles might need to be flipped more than once. For example, a line like east, southeast, west flips a tile immediately adjacent to its reference tile, and a line like flips the reference tile itself. Okay, so here's a larger example. In the above example, 10 tiles are flipped once and 5 more are flipped twice. So, why is this? This seems to be giving us it's giving us like 20 lines and seemingly 20 unique tiles. 1, 1, 1, 0, 1, 1. Like, we move XYZ in that direction for every direction in the directions, which is every line. And then we take a tile key, which is XYZ, and we set it to be flipped or not. And what we want to do, oh man, we're doing the same friggin' here. Same friggin' thing here. When T. So this is still giving us 20 rather. When T is true, yeah. So this is still giving us this floor where we're going through and we flipped all of these but it's giving us a different, it looks like it's giving us a different tile each time. So why is that? So we want to ensure that this, so let's try that, lay tiles. Okay, log lay tiles. And this is gonna give us the floor back, and we want to parse input that. This should flip the reference tile. And it's not flipping the reference tile. So northwest, west, southwest, east, east. Interesting. So this is, I mean, this is giving us a good indication that something's wrong. So let's log that. Northwest, west, southwest, east, east. So northwest would have +1 here. West would have +1 here, or -1 here on X. Okay, so let's go through this step by step. Let's log dir x y z, and then let's log. Okay, so let's see, and let's turn off this guy. Okay, so what do we got? We start with that, and we want to go northwest. So that is y goes up by 1. Then we start here and we go west, which goes -1 on the x-axis. Then we go southwest. And southwest is a third axis, which is -1. So I guess going east, it's not as simple as just doing these. This must be where it's wrong. I'm thinking about this as each one affects only one dimension, but maybe it doesn't, because I guess in this case, if you think about the tiles, going east, so if we are on a hex grid, what that's going to do is that's going to start us here, and then we're going to go northwest is going to take us here, and then west is going to take us here, and then southwest is going to take us here. Then we want to go east, east. And that should take us back to 0, 0, and it's not. It's taking us back to 1, 1, -1. So I think my understanding of hex math is wrong. So let's take a look at this link that they provided us, the hexagonal tiling. Hex tile. Coloring hexagons. This tiling is totally related to symmetry mutations. Okay. There's different types of hex tiles you can have. Okay, circle packing, hexagonal lattice. Let's go back up to the top. One, two. Oh, this is flipped sideways. Okay. It says 3 hexagons meet at each vertex. is the densest way to arrange circles. Yeah. Okay. Let's look up hex tile move. Hexagonal movement, Unity form. All right, video game. Okay, simple 2D game. That's not what I want. Get out of there. Go back. Hex grid. Yeah, hex grid move is what I really want. Hex grid. You can move only in 6 directions. Okay. Here we go. Do the math on diagonal movement. No. Difference is huge. Yeah, what we want to do is we want to figure out, okay, hex grid, here we go. I bet this site's getting a lot of traffic, or it did 2 days ago. Hex base, so 5 foot radius, okay, 30 foot radius. Yeah, what we really want to do is we want to, this is not helping. Hexagonal grids. Geometry. Okay, here we go. I've seen this before. Offset coordinates. Most common approach is to offset every other column or row. So, yeah, cube coordinates. This is what I was using. Another way to look at hexagonal grids is to see that there are 3 primary axes. Unlike the 2 we have for square grids. There's an elegant symmetry with these. Let's take a cube grid and slice out a diagonal piece at x, y, z equals 0. This is a weird idea, but it helps make hex grid algorithms simpler. In particular, we can reuse standard operations from Cartesian coordinates. Adding coordinates, subtracting coordinates, multiplying, dividing, scaling. Okay, sometimes we don't have obvious algorithms for hex grids. So this is what we're doing here. We're doing something like this, where we start here, and we are, oh, interesting. So when it moves in any direction, it actually moves, it moves plus or minus on the other axis. So it always affects 2 values, and here I've only got it affecting 1. So I've got this backwards, I think. So when we're moving west, so switch to hexagons. Oh, that's cool. That's awesome. Okay. So each direction on the cube grid corresponds to a line on the hex grid. Try highlighting a hex with, okay. The cube coordinates are a reasonable choice for a hex grid coordinate system. The constraint is that x plus y plus z equals 0. So algorithms must preserve that. The constraint also ensures that there's a canonical coordinate for each hex. And then we've got axial coordinates. And this might be closer to what I'm doing. QR skewed is built by taking 2 of the 3 coordinates from a cube coordinate. So there's some redundancy, and we don't need to store all 3 coordinates. That's interesting. So plus. So basically, this is saying, hey, when you go in this direction, you only affect this. When you go in this direction, you only affect that. And when you go in this third direction, you affect both. So maybe that's what we want to do here, is instead of x, y, and z, we can use an axial coordinate system. Then we would have, whoops, instead of z's, we would have one of these would be plus x minus y? No, I'm confused about this. There are many choices of cube coordinates. And doubled. Only going to use rectangular maps. No. Axial coordinates. So this is interesting. Coordinate conversion, axial coordinates, cube to axial. So hex QR are closely connected to cube coordinates. I liked the cube coordinate system. I guess I just didn't understand it. So X, Y, Z. So if we're on the x-axis, then we need to subtract and plus in that one. If we're on, this is probably the easiest way to think about it. And we don't need to track the actual position. We just need to be consistent. So let's assume that this is the x-axis. So let's just rejigger how we calculate this. So if this is x, in one direction, we'll say y plus equals 1, and z minus equals 1. And then we'll do it the other way. We'll say y minus equals 1, z plus equals 1. Then we'll do this the same way for these, except we'll substitute out. So this is going to be, instead of y, this is going to be x, and then now instead of, so this is z, so instead of z, we're going to have x. So in theory, this would give us the cube coordinate system here. Whoops. Yeah, so let's see what this runs. X. What line is this on? Line 68. Oh, I was drawing. Okay. So let's count the flip tiles here. This is still giving us like the wrong answer. It's still giving us 20. All right, so log parsen. So now, in theory, northwest goes in that direction. West, southwest. So maybe I've just arbitrarily done these, and I shouldn't be doing that. So southeast. So these share an X, and northeast. And then so south and east. So, yeah. So in this case, west and east are on the Z, or on the x-axis. Maybe I can't. Maybe what I need to do is I need to flip these. No, that also gives us the wrong. I mean, I'm just arbitrarily moving two directions, but that just arbitrarily flips. They just need to line up between west, east, southeast, southwest, north. Yeah, so I'm doing something wrong here. Study how the cube coordinates work on the hex grid. Okay, so here we are. If we apply the same logic here, so as we move x, y, z, so this is, so z is this one. So as we move, so let's follow their coordinate system, I guess. So east and west are z. That's the z index. So this would be z. So this would be x and y that need to move. So x and y. So we're still on the same z-axis. And x goes down 1 for west, and y goes up 1. So west, x goes down 1, and y goes up 1, and then vice versa for the other direction. And then if we follow the x-axis, which is northwest, southeast, which is the next one, southeast, northwest, let's go northwest, southeast. So northwest goes -1x, negative z, positive y. So negative z, and then positive y. Zy, and then positive z, negative y. Yep. And then what do we have? The third one would be the y-axis. So these are the y-axis. Southwest goes negative x, positive z. So negative x, positive x, and then this would be z, and this is positive z, negative z. Okay, and then so this does not give us the right answer, but I feel like we're closer. Each direction on the cube grid, okay. In the neighbors section, okay. Cool. So we're back to here, and this doesn't seem correct to me. So we're going. So we go northwest. Okay, so we start here. Let's go northwest, west, southwest, east, east. And this should take us back to 0, 0, 0, but it doesn't. So northwest is yz. So y plus 1, z minus 1. Yep. And then we go west, and that should give us, no, this is, so west is wrong. Why is west wrong? West, x minus 1, y plus 1, and then east would be x plus 1, y minus 1. And we can remove these now. So here we go. So this is where we went wrong. So we should now be going west, which would subtract, yeah, how do we subtract 2 suddenly? So this is subtracting 2. I guess we should, yeah, because otherwise, how is going west subtracting 2? That doesn't make any sense. Okay, no, see, this doesn't make any sense. So we're logging x, y, z, 0, 0, 0, and then 0, 1, negative 1, and then suddenly we're at negative 2, 2. So that doesn't make any sense. So maybe this, then let's pull these thens off. Okay, when, and we can say then, and then, and, okay, so let's try that. Okay, that makes more sense. Yeah, no, we're still back in the wrong position. Okay, so let's see. So is that and? Yeah, it was, whoops, come back. Okay, so in west, so here we go. We start here, and let's bring that back up. Let's track our thing. So we're moving once here, a second time, southwest, east, and east. So we have still screwed up somewhere. So we start here, we move up to here, plus 1, negative 1. Then we move west, and we're at negative 1, plus 2, negative 1. So x, y, z. Then we move southwest, and we should be negative 2, plus 2, and we should be back to 0. And we're not back to 0. So we went southwest, and we went to negative 2, plus 2, and we're still at negative 1 for some reason. So southwest. So southwest. Oh. Whoops. Typo. Excellent. And that brings us back to 0, 0, 0. Okay, cool. So that gives us the coordinate system that we cared about. So move was wrong. All right. Cool. So I guess what we can do is we can log that and see if it gives us 10, and it does. So now we no longer need to log those, and we can just assert that is that. Oops. And we still get a login here. That is login up here. Okay, cool. Neat. So that works, and now what we want to do is we want to run this. Log that on require input. And we need to get our input. Well, that was fun. All right, get your puzzle input. Copy, and we'll make our input over here. And let's say module.exports equals bam. And let's run 497. Let's see if that works. That's the right answer. Cool. Continue to part 2. Part 2. The tile floor in the lobby is meant to be a living art exhibit. Every day, the tiles are all flipped according to the following rules. Any black tile with 0 or more than 2 black tiles immediately adjacent to it is flipped to white. Okay. Any black tile with 0 or more than 2, this is kind of like Game of Life, is flipped to white. Any white tile with exactly 2 black tiles is immediately adjacent to it is flipped to black. Here, tiles immediately adjacent means the 6 tiles directly touching the tile in question, and the rules are applied simultaneously to every tile. Yeah, this is like Game of Life. Okay. In the above example, the number of black tiles that are facing up after the given number of days has passed is as follows. So, day 1 is 15. In the above example. So do we flip them? We flip them immediately, I guess. To every tile, put another way. Okay, so it's first determined. Okay, 100 times there would be 2208 black tiles facing up. How many tiles will be black after 100 days? Cool. So I think we can basically build off what we've done so far, which is always nice. But we'll find out. Whoop. Okay, so this is part 2. And we still want this input, so I'm going to keep this input. And I think, do they say anything about using in the above example? Okay, go through the renovation crews list. Okay, in the above example. So, you know, we're just going to keep our input. We'll just move it down to the test section. Here we go. All right. Plain. So then we want to flip it. Oops. Why did I do that? What is happening? Plain. These are the rules. Okay. So there's 2 rules to apply. Any black tiles with 0 more than 2 immediately adjacent to it is flipped to white. Any white tile with exactly 2 black tiles immediately adjacent to it is flipped to black. So what we're gonna need to do, we've got this floor. And now what we're gonna wanna do is, now that we've got the floor, what we need to insert this new step that is like flip floor, and it's gonna take a floor which looks like this, And what we're going to need to do is we're going to need to go through all the tiles. So for key val of tiles, I guess it's, yeah, of tiles. What we're going to do is we're going to make a new floor. New floor equals, whoop. And this new floor, we're going to set the values of each of these tiles based on the number of neighbors. And so the number of neighbors, this is going to be interesting, because we're going to have to consider every possible neighbor to these tiles as well. So we're going to need to, I guess what we'll need to do is we'll need to find out what the min and the max x, y, and z are, and expand those by 1, and then just go through every possibility. Because we can't just go through the ones that are already, that we've ever been to. Min x, max x. Yeah, is this really the best way to do it? I don't know. I guess what we want to do is we want to figure out what the min and max for x, y, and z are. We're going to have to flip, or we're going to have to parse the key. So we're going to say x, y, z equals key split on that guy. And then what we're going to do is we're going to run that through map parse float. So this is going to give us our x, y, and z coordinates. And then I guess we could do this manually, or we could just say x's, y's, or x's equals bleh, y's equals 0, and z's equals, so all of these equals that, and then we could say x's dot push x, and then this is y, and then z. And then at the end, what we'd want to do, so this is going to give us the bounds. So maybe we can pull this out. We can say bounds, and that takes a floor. And what we're going to do is we're going to, and it's not of tiles, it's of floor. And then we'll give back. We're gonna want to max x, max y, min x, min y. So this is gonna give us back math dot min x's, and then max x's, oops, y's and z's. Ugh, that's awful. All right, this is going to return the min and max for x, y, and z. So got that. So now we can yeah, so we're gonna start, I guess we'll start at the min for x and so, okay. So we're gonna say max x. I guess we could do this, whatever. So this is gonna give us min x, max x, min x, max x. And we're gonna do that 3 times. And this is gonna be y, and then z. equals get bounds for floor. Okay, so this is gonna give us our bounds, and then for x in, now we're gonna want to do min x minus 1 up to, and not including max x plus 1. So we're going to do that. Then we're going to do it again for y. Oops. Y. Y. And then again for z. Okay, so we have our existing floor and we have our new floor. And what we're trying to do is we're trying to apply these two rules. Okay, so we're going to try and apply these rules. Whether any black tile with 0 or more than 2 black tiles will immediately be, so we need to calculate the number of neighbors. Any white tile with exactly 2 black tiles is flipped to black. Okay, so we need any white tile with exactly 2 black tile neighbors, and then any black tile with 0 or more than 2 black tiles. So num black tiles equals, so we're going to need a new function here. It says count black tiles. This is going to take in a floor x, y, z. All right. So we're going to take in x, y, and z. So this is going to be a coordinate on the floor, and then we need to do okay, so min, oops, come here. So x minus 1, we're going to do the same thing for max. And we want to skip, so there's 6. There's x before, that would be 8, but we want to skip this one where x is 0. 1, 2, 3, 4. So if we check, this is going to give us 8. So maybe this is not what we're, no, because we need to do this thing. So we just basically need to move in each direction, move in each cardinal direction once. So so this is not how we want to count the neighbors. What we want to do, and maybe this is not how we want to do the flip floor. Maybe what we want to do is we want to move outwards. Yeah, this is where it gets complicated. All right. So for dir in, and then what we got here, you know, let's make it easy on ourselves and just say west, east, southwest, southeast, northwest, northeast, split on that. So for direction in those directions, and then we're going to say sum equals 0, and just say sum plus equals 1 if, so we're going to say, what do we want? We want new chords. We want new x, new y, new z equals move. And what does move take? Just x, y, z direction? Yeah, x, y, z direction. Okay, if floor And we got to generate our key again. Maybe this key should be its own method. Tile key. I mean, it's not really. Let's make it one anyway. Tile key equals X, Y, Z, and we can just say oops, X, Y, Z join. That could be just chords, but whatever. Tile key equal tile key X, Y, Z. So, whoops. Tile key X, Y, Z. Okay. If floor tile key X, Y, Z. So if it's flipped, that's the number of black tiles. Okay. And return the sum. So that's count black tiles is count black tiles for, and then was it X, Y, Z. So this is gonna give us a lot of coordinates that don't exist, I think. Let's see how bad it is. Okay, so we're gonna say new floor tile key XYZ. So if floor tile key whatever. So if floor tile key, if it's black, and 0 or and numBt is 0 or 4, or numBt is 0 or is not 1 isn't 1, so it could be 2 or more, or more than 2 isn't or not in. So basically if it's 1 or 2 then we don't want to do it. Equals true, so we're gonna flip it. Else it would stay the same. Is that what it is? Any black tile with 0 or more is flipped to white. Okay, so if it's black, so if it's white, then it stays the same. So we'll just say cur. This is the current state. It stays the same. Else it is flopped. It's flopped to cur. not. Okay. Okay, and if it's a white tile and it has exactly 2 black tiles, it's flipped to black. So this is the white tile. So if numBt is 2, then it's flipped to black. So new floor tile. So any black tile with 0 or more. I guess what we want to do is we want to say new floor tile is set to whatever the current one is. So and then if so this is going to be the current tile. So if current, then not in. We flip it. Okay, so if the current tile is flipped and the number isn't in that, then we flip it. And else, and then we say if not cur and numbt is 2, then we flip it. Okay, and then at the end of all this, we want to return the new floor. So we'll return the new floor. So, hot damn. All right, what do we got here? In the example above, the number of black tiles. Okay, so we're gonna flip the floor once. So we got lay tiles. So let's try this. Let's floor equals lay tiles, and then we're gonna log count flip tiles lay floor. Log count flip tiles floor, and this should give us. Oh, this is angry. Wait, what line is this on? 118. 118. Okay, so cool. This still gives us the same answer. That's cool. So now what we're going to try and do is we're going to try and flip the floor one time, and then say count flip files of flipped tiles of the flip floor. Flip floor. Okay, cool. Reference parse float is not defined. Well, let's fix that. Parse float. So this gives us 0, which is not what we were going for. And I wonder if it actually went over these. So I feel like the way that we're handling the coordinate system is wrong, where we're iterating over every possible x and y value. Because if we look at our hex grid over here, I mean, no, that seems about right. So we go to 3, and these are the 2s, and then these are the 1s, and then this is the 0. And I guess what we can do is we want to continue if x is y is z is 0. So let's log roll and then continue. It never does this. So that's up to, oh, and not including max x, so maybe we want to include it. Let's log x, y, z. So it's not even doing this. Bounds floor. So let's log bounds floor. Nan. Okay, well, here we go. That's a problem. I guess what we need to do is we need to do that. Haha. Okay. So that's neat. So now we're logging those. And are we ever log continue? Is it where are we logging that? Count for tiles. Log. Oh, here we go. Cool. So yeah, we do log it exactly 1, so that's fine. We can continue because we're actually not. But we don't actually want to continue. We want to check it for everything because we don't want to skip the 1. Okay, so this is. Let's log a new floor here. See if we're actually producing a new floor. We are. Everything's undefined. Okay, we got some falses in here, so that's good. And let's log numbt. Log numbt. So we'll see what this gives us. So it's mostly if numbt. Oh, okay, look at that. So a lot of them have 6 flipped neighbors. And that's it. That doesn't seem right to me. I think this count BT is wrong. Okay, so for directions, we're gonna move if for tile. This is gonna be new X, new Y, new Z. Oops. Let's try that. Okay, that seems more reasonable. And look, we're getting 15, which I think is the answer that we wanted. Okay, so let's, what are we logging? We're still logging something? We're still logging this. Okay. So this is giving us 10, then 15, which according to the problem, it should be doing it after day 1, and then day 2 should be 12. So let's make sure that that is also true. I guess what we want to do is we want to flip the floor twice, and we want to say floor equals flip floor, and then floor equals flip floor. So that's going to give us twice, and then we'll count the flip tiles of the floor. That gives us 12. The next one should be 25. 25, beautiful. Okay, so we want to do 100 days. So we're going to need another thing up here that basically just does this. So flip floor. Oh, we have flip floor. Well, we'll iterate floor, and that's going to take floor and times can equal 0 to start. Floor equals, it's going to be one of these. And what we're going to do is this is just going to be, say, for I in 0 up to and not including times. We're going to say floor equals flip floor floor floor. Cool. And then we're going to return floor. So iterate floor. So, and this is, yeah, okay, so we're gonna, this is gonna just be iterate floor 3, and then floor 3, and then log that. Oops, that should still give us, okay, no, it didn't do it. Let's give us 10. Floor 3, I guess what we want to iterate floor times, floor equals that, and then we'll flip this back times. Okay, that gives us 25, 2 gives us 12, 1 gives us 15. Okay, beautiful. So 100 gives us, oh, it's thinking about it. Should give us 2208, and instead it's freaking out. Maximum call stack exceeded. Well, hot damn. Let's try 50. Let's try 10. Iterate floor 10. Day 10 is 37. Okay, day 20. Why is this getting so big? Day 20 should be giving us 132, and it does, but it's getting geometrically. It's getting geometrically more computationally expensive. And why is that? Is it because the grid, I mean, the grid is growing cubically, possibly. So maybe this, and it's saying maximum call stack exceeded. So that's, I mean, that's crazy. So we got this new floor. So maybe it's partly this. Maybe what we, because this is going to grow the cube out regardless of whether or not there's a value. Well, it's going to do min max. Up to, well, it's going to be up to and including max whatever, so we can get rid of the +1. We can get rid of these. Still going to give us, nope, that is not going to give us those. Interesting. So it's up to max of, oh, right, not up to, right, okay. So if it's currently black, if it has number of neighbors, it wants to be white, not black. So it would be flipped. So that would be go to false. Else it goes to true, which it currently is. Else it remains true. But this would be new floor. Okay. If it's not, but it's neighbors, then it goes to flipped. So then that way we don't have to set it every time. So maybe that'll be faster. 3.6 seconds? No. Cur is not defined. Where am I using cur? If cur equals, let's not set this, is all I'm saying. Okay, so that was much faster. Okay, so because we're not setting it. Okay, so that's 20. So what else we got? 30, 259, 30. Let's see, it starts to get slower. 259, 40, 406. Whoops. 40. Getting slower geometrically still. So 3.5 seconds. Okay, so we're ahead of the game a little. 50. 566. So I don't know if we're gonna make it to 100, because I think it's getting considerably bigger with every iteration. I mean, we can try, but I have a feeling it's going to hit that maximum call stack again. And why is it hitting a maximum call stack? Because that's where we've nested. I guess what we could do as well is the bounds. So when we get the bounds for something, what we want to know is we only want to go over the keys of the floor when it is true, when val. Okay, so let's cancel that, and let's see if we go back to 50 is faster. So this took like, I don't know, 10 seconds last time or something, 7 seconds. 8.4, and if we remove that and we run it again, let's see what we get. .4, so it doesn't really matter. Balance true. I mean, this should be exactly the same. So these are the bounds, and really, I guess what we're doing is, I mean, it's going to be like Game of Life, where we're like, we've got little like clusters moving out, and it's really only the clusters that we care about. It's not the overall board bounds. So maybe that's what we need to do. Maybe what we need to do is we just need to investigate the clusters. So instead of bounds, maybe what we want to do is we want to evaluate all the neighbors. So we want to collect the X, Y's, and Z's of all the tiles that are currently flipped, and we actually want to collect the X's and Y's of all the neighbors. So we want the tiles plus or minus 1, or the coordinates plus or minus 1 for every black tile, and if that's the space that we want to examine, because those are the only possible ones that could have a neighbor that we care about. Okay, so that way we'll get sort of like a more granular blob. So I guess what we want to do is, instead of bounds, what we want to do is we want like active coordinates. And so we could either unique them, or we could use a set, like a JavaScript set. Script set. So what is it? Set add. Okay. Equals new set. Oops. New set. New set. And then where val is true, so when we have flipped it, what we want to do, okay, it's going to split the key, and push 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 becomes add, and we're going to say X minus 1. Can we add multiple things? Add. Yeah, I don't know if it doesn't seem to allow us adding multiple. Yeah. Okay. Well. Okay. Whoops. There we go. Here. Come on. Too many. And then we're not doing this math min whatever. We're actually just returning XS, YS, ZS. This is awful. And then this would be minus 1, plus 1, minus 1, plus 1, minus 1, plus 1. So I mean, like, this is just some shitty whatever. We'll see if we can make it work, and then we return that. So this is active chords. So instead of min whatever, we're gonna say for x's, y's, and oh, that's interesting. This is gonna give us a series of coordinates that we need to check. So this is gonna give us, maybe what we can do is we can just, yeah, for key val of floor when val is true. So maybe this is what we want to do, is not, instead of, because that would give us, yeah, okay, so flip floor, that's going to be for key val xyz equals that. And then what we want to do is we want to say for, we want to find all the neighbors of each of these, and that would be move, right? For new x, new y, new z, in move x, y, z. So what we're going to want to do is we're going to want to find all the tiles. And those tiles are going to be kind of a set because we're going to duplicate the set, but that's fine. We can test some of these several times. In move XYZ. Now what we want to do is this. Count to, so this would be new X, new Y, new Z, new X, new Y, new Z. In fact, yeah, whatever. New floor tile, new X, new Y, new Z, new X, whoops, new Y, new Z, new X, new Y, new Z. Could have just named these in retrospect differently. All right, let's see if that works. So this is undefined is not a function on line 121. In move XYZ. Yeah, I don't know why I'm doing this. What we'd want to do is equals move for, yeah, wow. So I've just like got this completely wonko. All right, so what do we want to do? We want to move in each of the 6 directions, and we're actually doing that for count BT. So what we want to do is that we want to move right. We want to do exactly what we're doing here. So for direction and whatever, we make the new X, new Y, new Z, and then we count those. And then 566 after 50. Oh, that's much faster. Okay. And we didn't need to use set at all. In fact, we don't need this whole active coordinates bullshit. We can just do it here. So 566 after 50, cool. Now what is it after 100? Let's see if it still works in 100. 2208. Okay, cool. So that's what we wanted, and we wanted to assert whoops, was it 2208? A is iterate floor 100, and then okay, so is lay tiles, count flip tiles. Iterate floor 100, lay tiles, parse input. I think that's correct. Yay! Okay, and now we need to actually log the thing here. Parse input, require input. So it take a bit longer. And let's see, what is it? After 100 days, so 4156. Let's try it. That's the right answer. Cool. All right, that's day 2, or not day 2. That's part 2 of day 24. Okay, so woo, let's go through and take a look and refactor. Okay, so parse input, splitting on new lines. Each line we just match these. Because we're matching them in an order, it should be greedy, and it is, and that works. Then we've got this idea of moving. So this moving thing we got from this hexagonal grid thing. We just sort of like see this. So we're looking at that cube coordinates. So that's what we're looking for, is cube coordinates. I wonder if there's like, can you, oh yeah, look at that. Beautiful. Copy link address. Whoop, coordinates cube. So this is where we're getting this move from. So we're switching on the direction, west, east, northwest, southeast, all that. And we did the same thing there. So I'm leaving these notes just for future me. Like this is where we got this idea from. and we are going to, come on. Somehow, there we go. So parse input down to here. There we go. This is where we got this idea of coordinates and moving the coordinates. The tile key is a method. Lay tiles, I think, is the same, except we have tile key inline. Does this still work? 497? I assume so, yeah, because assert works. Yeah, let's try this. 497, okay. So we got our tile key, which is just the args joined. What if we could just do that? Just arguments join. Anyway, whatever, doesn't matter. So, okay, so for directions for directions that we want to move in our instruction set, we reset those, and for the direction and directions, we move, and then finally we just flip it to the opposite of whatever it was before. So if it was undefined, it becomes true. If it was false, it becomes true. If it was true, it becomes false. Okay, and then we return the floor, and then count flip tiles. We could also just like count the number of things which is true. I mean, yeah, we've been through this so many times before, and it's always like, oh yeah, we could actually just reduce it to an array of truthy values and then check the length of that array, but I don't think it's any faster. I don't think it reads particularly better, so I'm fine with just keeping it. I don't even need that parentheses. The fewer parentheses I can have when I'm writing software, the better. Okay, assert 10 is count the flip tiles of lay tiles of parse input. Okay, I think that's fine. And then part 2, this is a bit more. It's a bit more involved because we've got count the black tile neighbors. So count, maybe this should be count neighbors. Neighbors. We'll really piss off the Americans by adding a U. Okay, and it should still work. So this is for directions. New x, new y, new z equals move, and then we add one if tile key of that. In fact, we could just say like that, and then it would explode. So let's put it back. Okay. So flip floor. So for key val of floor when val is true. So basically what we're doing is, we don't need this is true nonsense. So basically what we're doing, come on, is we're going through all the truthy tiles. And what we're doing is we are grabbing the XYZ of those. And what we're doing then is we're looking for all its neighbor. We're evaluating all of its neighbors. And this is going to evaluate a lot of tiles twice because this guy's neighbors include this guy's neighbors, at least 2 of them. But that's okay because it's fast enough and it doesn't matter. We could have a cache of like scene values, or we could collect the XYZ coordinates that we want to evaluate, and that would make it faster. And I mean, we could, but I don't think it's a big deal because we got it fast enough. So I'm not going to be bothered to do it. So this is what we're doing. For every one of these, we are evaluating the neighbor. And this is basically, we're just applying the rules. So we're getting the current value, and we're getting the number of black tiles, which is count neighbors. And then we're saying if it's currently a black tile and the number of black tile neighbors is either 0 or 3, 4, 5, 6, then we are turning it off. We're flipping it back to white. Otherwise, we are flipping it, or we're just leaving it as true because it was already true that it was flipped. So that way we're only modifying the ones that we care about. And then if it's not flipped, but the number of tiles is 2, then we flip it. And then we return a new floor. And then counting flip tiles, the exact same thing. Don't need these parentheses because why do we need them? And iterate floor is just going to apply the transformation. It's going to apply the flip X times. And that's exactly what it does. We've got our input, we assert that this is correct, and then we log out the proper answer at the end. So yeah, I think we're done. That's day 24 in the bag. I'm going to I'm gonna commit it there. So that's cool. And then tomorrow we can do day 25. Cool. So README, we updated this already, lobby layout, and we added all that stuff. Cool. Day 1, day 2, and the input. Cool. So that's day 24. And cool. I think that's about it. I will see you guys probably tomorrow for day 25, the last one. Excited. It's gonna be good.